Okay, hello everybody. We're gonna get started now.
Hello.
Is everybody not muted?
You can mute ourselves.
I'm gonna. I think that worked. Oh, there we go. No, I got it now. Okay, so we're set. Okay, so we're going to start where we left off with geometric series. And we covered that a bit quick last time, so I'm just going to briefly write down a few formulas to memorize. So okay, there you go. So the nth term of a geometric series is always going to be the first term, a, times the common ratio to the n minus 1 power. And the sum formula for the first n terms of a geometric series is always going to be the first term times the common ratio to the nth power, where n is the number of terms, minus 1 all over the common ratio minus 1. And for an infinite series, where the absolute value of the common ratio is less than 1, the sum of it is equal to the first term divided by 1 minus the common ratio. And this only works if the absolute value of the common ratio is less than 1, because if it's greater than 1 or equal to 1, then our infinite series sums to infinity. So if everybody's clear on that, then let's move on to the next page. So we have our problem here, and it's asking for the sum of the infinite geometric series 2 plus 1 plus 1/2 plus 1/4 ... And I'll remind you that the formula for this is the first term a divided by 1 minus the common ratio r. So I'll just give you guys a few seconds to think about that. Okay, so we're back here and let's solve this problem. The first term a is the first term written right here, which is 2. And our common ratio r is equal to 1/2, because we know that 2 times 1/2 is equal to 1. 1 times 1/2 is equal to 1/2. And 1/2 times 1/2 is equal to 1/4. And 1/2 is definitely less than 1. So we know that it's possible to find the sum of this. And so if we plug everything into our formula, then we get 2 divided by 1 minus 1/2, which is equal to 2 divided by 1/2, which is equal to 4. And the answer here is 4. Okay, so next question here. What is the sum of the geometric series 3 plus 9 plus 27 all the way to 2,189? Whoopsies. Okay. You totally didn't see that, guys. Well, I guess we'll have to continue like this. Okay, so we can tell that this is a geometric series because we know that 3 times 3 is equal to 9. 9 times 3 is equal to 27. And so we can tell that the common ratio here is 3 because we always multiply by 3 to get the next number. So if you recall, our formula for the sum of a finite geometric series is a times r to the n minus 1 divided by r minus 1. So we can tell that a is equal to 3 because our first term here is obviously 3. Our r is also equal to 3 because, as we just established, the common ratio is 3. And then we're left with our n here. So to find out what the value of n is, we're going to have to find a pattern here. So we know that 3 is equal to 3 to the first, 9 is equal to 3 squared, 27 is equal to 3 cubed, and if we go on, we can see that 3 to the fourth is equal to 81, 3 to the fifth, we multiply by 3 again, it's equal to 243, 3 to the sixth, we multiply by 3 again, we get 729. And 3 to the seventh, when we multiply by 3 one more time, we get 2,187. So we know that our pattern starts at 3 to the first and ends at 3 to the seventh. So then how many terms is that? Well, we covered all the numbers 1, 2, 3, 4, 5, 6, 7. So that is 7 numbers. So our n here is equal to 7. And we can plug all our numbers into our formula. A is 3, R is 3, N is 7, and this number should come out to 3279. So is everybody clear on that? And don't forget, guys, if you have any questions, you can just message them to Benjamin. And also a reminder, please don't spam in the chat. If you spam in the chat, then we'll have to either kick you out or mute you. So. Okay, so our next topic today is going to be recursion. So we are going to go over the definition, recursive formula, and some examples. So basically, recursion is, well, let me give you one of the more famous examples of recursion, and that's the Fibonacci sequence. So if we have the terms 1, 1, 2, 3, 5, 8, 13, and so on. Can you guys find the pattern in this sequence? Well, you see that 2 is equal to 1 plus 1. 3 is equal to 2 plus 1. 5 is equal to 3 plus 2. 8 is equal to 5 plus 3. And 13 is equal to 8 plus 5. So this is basically the Fibonacci sequence, which kind of follows a weird pattern, but we can write this pattern in terms of algebra. If we let our sequence be A1, A2, A3, A4, ... Then following the same pattern as we have here, we know that A3 is equal to A2 plus A1. A4 is equal to A3 plus A2, ... So in general, if we have a term AN, what would that be equal to? Well, then that would be equal to AN minus 1 plus AN minus 2. And you can also tell because 2 is always 1 less than 3, 3 is always 1 less than 4, and n minus 1 is always 1 less than n. And if we see here, 1 is always 2 less than 3, 2 is always 2 less than 4, and n minus 2 is always 2 less than n. So this here would be the recursive formula of the Fibonacci sequence. And then, of course, you would have to define your starting terms. So this would be if A1, the first term, is equal to 1, and A2, the second term, is also equal to 1. And some sources say that it starts at A0, but that's really a matter of preference. And you see that, for example, if we had started with different starting terms, like if I gave you that the same formula, except that if A1 was equal to 1 and A2 was equal to 2, then that would produce a completely different sequence. For example, we would have A3 is equal to 1 plus 2, which is 3. A4, oh wait, no, that wouldn't give a completely different sequence. Well, it would be shifted over, but it equals 2 plus 3 equals 5, and so on. So we see that, for example, here our third term is 3, but here our fourth term is 3. So if everyone is okay with that, then we're going to do another example here. What is the recursive formula for the sequence 2, 3, 8, 19, and 46? So I know that recursive formulas might be new to some of you, so I'll give you guys a little more time with this problem. Okay, so right now it seems like people are spamming in the chat. So let me try something here. Oh, whoopsies, accidentally revealed the answer there. Okay, so I tried to make it so that attendees can only chat with the host. So maybe that will be a temporary fix for now, and we'll try to come up with something later. Okay, so back to this problem. So we can try to look for the pattern in this sequence. And patterns are sometimes hard to find. So for example, you can tell that here, the same rule as last time won't work, because 2 plus 3 is equal to 5, not 8. 3 plus 8 is equal to 11, not 19, and so on. So if you play around with this pattern a little, you'll find that actually 2 plus 2 times 3 is equal to 8. 3 plus 2 times 8 is equal to 19. And 8 plus 2 times 19 is equal to 46. So then our pattern would be, if we had the sequence A1, comma A2, comma A3, so on, we see that A3 is always going to be 2 times the term right below it, which is A2, plus 1 times the term right below that, which is A1. And in general, we can see that AN is equal to 2 times AN minus 1 plus 1 times AN minus 2. And then you can see that is the equation part of our solution. But as we know, this formula right here could be true for a lot of different sequences. So what we have to do is we have to define our starting terms. And in this particular sequence, our starting terms are A1 equals 2, and A2 is equal to 3. And so right here is our solution. Whoa, what the heck just happened? Okay, okay. Right here is our solution. And you can see that is the same thing as the thing in the red box. Oh, guys, I just saw a few questions in the chat. If you have questions, please send them to Benjamin, because I don't have the time to look at all these things in the chat. So thanks. Okay. Okay, so next we are going to go over telescoping. So telescoping in essence is very simple and also very satisfying. Like, for example, if I told you guys, what is the sum of the numbers 1? Hang on. Where did my annotate go? Okay, so if I told you guys, what is the sum of 1? Hang on, let me try to find an example. 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8. What would the answer to that be? Oh, sorry, guys. I just realized you guys can't talk to Benjamin. So I'm going to, until we come up with a better solution, I'm going to turn the chat back on. But you guys have to promise not to spam, okay? Okay, so anyway, you could just go about this like, what is 1 minus 2? Well, that's -1. And then what is -1 plus 3? Well, that's 2. What is 2 minus 4? That is -2. And you could keep doing this on and on until you get to -8. But that would not be the best solution. Because what you could do is this. If you see our original expression, we can cleverly regroup them like this. Because addition can happen in any order. 1 minus 2 is -1. 3 minus 4 is also -1. 5 minus 6, -1. And 7 minus 8 is -1. So 4 negative ones added together will give you -4. And so this is basically what telescoping is. It's basically being given an expression to find the value of, and trying to exploit patterns in that expression so that it can be simplified into something much smaller than what it actually is. And there's no real method to do problems with telescoping, so you just have to do some practice and get used to it. So let's do a practice question right now. Okay, so this is relatively simple. From the 2018 AMC 8 problem 2. What is the value of the product 1 plus 1 over 1 times 1 plus 1 over 2 times 1 plus 1 over 3 times 1 plus 1 over 4 times 1 plus 1 over 5 times 1 plus 1 over 6? So let's get started here. 1 plus 1 over 1. If you convert 1 to 1 over 1, if you convert 1 to 1 over 1, then you have 1 over 1 plus 1 over 1, which is equal to 2 over 1. And if you convert 1 to 2 over 2, and plus another 1 over 2, then you get 3 over 2. And similarly, 1 plus 1 over 3 is equal to 4 over 3. 1 plus 1 over 4 is equal to 5 over 4. 1 plus 1 over 5 is equal to 6 over 5. And 1 plus 1 over 6 is equal to 7 over 6. So really what we're doing here is we're doing 2 over 1 times 3 over 2 times 4 over 3 times 5 over 4 times 6 over 5 times 7 over 6. Oh, sorry. So what we can do here is we can cancel the 2's, cancel the 3's, cancel the 4's, cancel the 5's, cancel the 6's. So the answer here should be D7. Okay, onwards. So now we are going to go over some useful formulas. So these are formulas that are particularly useful in finding patterns or in contest math like the AMC 8. So the first one we have here is that, hang on, 1 plus 2 plus 3 all the way to plus n is going to be equal to n times n plus 1 over 2. Our second formula here is going to be 1 squared plus 2 squared plus 3 squared all the way to plus n squared is equal to I believe it's n times 2n plus, hang on. N times n plus 1 times 2n plus 1 all over 6. And we are running a bit short on time here. So let me just say that if you guys want to learn how to prove any of these formulas, then what we can do is we can have a class where we just go over induction, which is a proof method by which we can prove all of these different formulas. So guys, please stop cursing in the chat. So let's see if we have time here just for a challenge problem. Challenge problems. And our first challenge problem comes from the 2016 AMC 8, problem 19. So the sum of 25 consecutive even integers is 10,000. What is the largest of these 25 consecutive integers? So I'll give you guys a little more time to solve that since it's a challenge problem. Okay, so let's get started here. So actually, we may not have enough time, but okay, so guys, we might not have enough time, but I'm just going to go ahead and do this problem. And if the Zoom meeting cuts out, then it cuts out. And what will happen is that Benjamin is going to host a question and answer session starting from 6:40 until 7 o'clock. And the details are in the Google Classroom. So if you guys have any questions on anything related to math, you can ask him there. So let's just start doing this problem. So we see that it says 25 consecutive even integers. And what does that mean? Well, an even integer is divisible by 2, which means that it has to have the form 2 times some other number we'll call k. So we know for a fact that this number, 2k, is definitely even. So we can construct an algebraic equation, 25 consecutive even integers. Now there are two ways to do this problem. One is better than the other, but I am going to show you two ways. The first way is if our first term is just 2k. And our second term, since even integers are always 2 apart from each other, is 2k plus 2. Our third term is 2k plus 4 plus dot 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 all the way until when we have 25 terms. And if to determine what we add here, because we know it's going to be 2k plus something, what we can do is we see that the first term here is plus 0. The second term here is plus 2. Our third term here is plus 4. And so our pattern here would be that 4 is 2 times 2. Let me just write that here. 4 is equal to 2 times 2. 2 is equal to 1 times 2. 0 is equal to 0 times 2. And we see that 1 is always 1 more than 0. 2 is always 1 more than 1. And 3 is always 1 more than 2. And since we want the 25th term, what we need to do is we need to go 25 minus 1, which is 24, times 2 gives us 48. So we know that the number here has to be plus 48. So let's just erase all of this. Okay, so they say that this sum is equal to 10,000. And they're asking for the largest of these 25 consecutive integers. And the largest one is here, 2k plus 48. So let's group our terms together. Since there are 25 terms here, and each of them has 2k in it, we know that 2k times 25 is the number of k's, plus 0, plus 2, plus 4, all the way until plus 48 is equal to 10,000. So 2k times 25 is equal to 50k. And there are several ways we can approach finding the sum of this. We could either factor out a 2, which would give 2 times 1 plus 2 plus all the way to 24 equals 10,000. Or we could use the arithmetic series formula that I gave you last class, but let's just go with here. And if you remember, we had a formula a couple slides ago that gave us the answer to this. And that formula was n times n plus 1 over 2. And n here is 24. So we would have 50k plus 2 times 24 times 25 over 2 is equal to 10,000. And our 2 here is cancel out. And we have 50k plus 24 times 25 is equal to 10,000. Now, for this course, I am going to assume that all of you know some form of algebra. And so I do not have the time to actually solve this, but from here, you can subtract 24 times 25 from both sides, divide by 50, and then you would get what k is equal to. And since they're asking for the largest of the 25 consecutive integers, we must find 2k plus 48. So what you would do is plug k into 2k plus 48, and then that would be your answer. Now, a smarter way to do this problem would have been to use telescoping, or the same kind of pattern finding that we find in telescoping, and saying that instead we could do this. Let's set our middle term equal to 2k instead of our first term. And you'll see why in a second. Then our next consecutive even term has to be 2k plus 2 plus 2k plus 4 dot dot dot. And then on the other side, we would have 2k minus 2 plus 2k minus 4 dot dot dot. And so since we have 25 terms in total, we have 1 in the middle. That means there are 12 terms here and 12 terms here. And so what you can do is we can regroup the terms and say, wait a minute, negative 2, positive 2 cancel out. Negative 4, positive 4 also cancel out. And then we would keep doing this. Then we would eventually get just 25 terms of just 2k. And then obviously from there we could solve our k. And since they're asking for the largest, our largest is no longer 2k plus 48. It would be whatever the last term here is, and then that would be our answer. Hopefully I didn't go a little too fast there, but our answer to this problem would be E, which is 424. And right now we are out of time. So maybe next class we could do this telescoping problem just as a warm-up and then start with our next lesson. So I hope everyone here enjoyed the class. And don't forget that you have Benjamin's question and answer session to look forward to until 7 o'clock. And the room information is posted on Classroom. And that's about it. We're done. So thank you all for coming, and I'll see you next time.